So today we'll be discussing lesson 5, which is on net ionic equations. So many important reactions take place in water, and this is also known as aqueous solutions. It's often abbreviated as AQ, similar to how it is down here. When these reactions occur in water, many ionic compounds dissociate or separate into anions or cations when they're in water. So we were talking about anions and cations earlier in the year, and they're coming back around now. So the first thing you need to be familiar with is the vocab for total ionic equation. So a total ionic equation is an equation that shows dissolved ionic compounds that dissociate or as dissociated free ions. So to write the net ionic equation, you want to write all aqueous ionic equations as their anions and cations separately. So this first example down here, we have silver nitrate reacting with sodium chloride, and then that's going to form silver chloride and sodium nitrate. So the first thing you need to do is identify any aqueous compounds, okay? So you don't want the solids, basically. So we're not really going to be able to break this apart because it's a solid. It has to be aqueous. So these three we can break apart into their anions and cations. So the first thing we would do is we would take silver nitrate, since it's listed there first. We're going to dissolve that first into the anions and cation. So we would have Ag plus 1. And that's going to be aqueous as a label, since to show that it is dissolved in water. We're going to have nitrate. So NO3 minus 1 as nitrate. Sodium chloride is going to dissociate too, so we're going to have Na plus 1, Cl minus 1. So this is where knowing the charges on the periodic table is going to be essential for you to kind of break these apart into the anions and the cations. Then on the other side of the reaction here, we're going to have, I'm going to write that down here. So silver chloride is going to stay as a solid. We can't break that up because it's not aqueous. So you're just going to copy that down. So we're going to have AgCl with a solid label there. And then we can break apart sodium and nitrate. So remember that nitrate is a polyatomic, so you leave the whole thing together as NO3 minus 1. So this would be the total ionic equation for this reaction. I broke apart anything I could that was aqueous into these anions and cations. Now, when we talk about spectator ions, these are going to be ions that appear on both sides of the equation, and therefore it's not directly involved in the reaction. So you need to be able to identify spectator ions and know when you're looking at the reaction if you have any spectator ions, if you do, what they are. So we're going to identify any spectator ions in this example we just worked through here. So the solid has to stay alone. It's not even an ion, so you can't touch that. The next thing you want to do is look for ions that appear on both sides of the equation. So, for example, I read across silver, I can't cross out because that's in this solid here. Next I get to nitrate. Nitrate appears here as an ion as well, so I can go ahead and cross those out. So that would be a spectator ion, NO3 minus 1 nitrate, since it does appear on both sides of the reaction. Then I'm going to keep reading. So sodium is here as an ion, so I can cancel that one out. That's going to be a spectator as well. And then chloride here matches up with the chloride as part of this solid, so we can't cross that out. It doesn't look exactly the same. So now we've identified the spectator ions, and we can use that information to help us write the net ionic equation. After the spectator ions are canceled from the total ionic equation, the remaining equation is the net ionic equation. So this equation only shows the particles that are directly involved in the chemical change. So to write the net ionic equation for the above example, we crossed out these two ions because they appeared on both sides. So when we write the net ionic, we're just going to forget about those essentially because they're just spectators. And we're going to write what's left. So we're going to forget about the spectators that we canceled out, so these four here, and we're just going to write the remaining. So this would be your net ionic equation. So this is total ionic with spectators, net ionic once we've gotten rid of the spectators. So here's another example that you can try to practice. Basically it's very similar. You want to look for anything that's aqueous that you can break up, so that'd be this lead nitrate here, this acid here. This solid you can't touch because it's a solid, and then we have this acid as well, which you're not completely sure of the name of those yet, but that would be nitric acid. After that, the problem that I want you to try tonight for homework are all of the problems under lesson 5 of the problem packet, so give those a try, and let me know if you have any questions.